This is question 4 from the November 2017 chemistry HL paper. The question gives us two compounds, phosphorus trifluoride and phosphorus pentafluoride, and we are asked to draw the Lewis structure and write down the molecular geometry and bond angles for both the compounds. Let's get started. So for the first compound, phosphorus would be our central atom, and fluoride would be our remaining atoms. So we would draw the single bonds for both of them. And to figure out how many total bonds are there in this Lewis structure, you would have to go to the periodic table and count the number of valence electrons. So phosphorus is in group 15, meaning it has 5 valence electrons, and fluoride is in group 17, which means it has 7 valence electrons. And since we have 3 fluorides, it would be 5 plus 7 times 3, which gives you 26. Divide this by 2, you get 13, meaning you have 13 bonds in this compound. So we have 4 here, 8 here, 12 here, and since we need one more bond, it will be a lone pair. Same process followed on for phosphorus pentafluoride. Phosphorus is our central atom. We draw the fluorides with single bonds. Okay. Since we have 5 fluorides instead of 3 from last time, this previous step would just add 5 to this. This should be a times rather than a plus. So let's fix that. There we go. That would give us 40. Oh. So this gives us 40, which means we have 20 bonds. So let's see. 4, 8, 12, 16, and 20. So that's the first part of the question done. Then it says to find the molecular geometry of both of them. So here we have 4 electron domains, but 1 lone pair, which gives us the shape of a trigonal pyramidal. And then for the second one, since it's only 5 electron domains and no lone pairs, this gives us the shape of a trigonal bipyramidal. As for the bond angle, since this is so this is tetrahedral because it has 4 electron domains. The bond angle is 107 because the tetrahedral shape has a bond angle of 109, and since it has 1 lone pair, you subtract 2, which gives you 107 degrees. And for this, you would have 2 bond angles because the angle from the axial to the equatorial is 90 degrees, and equatorial to equatorial is 120 degrees. There. So your answer here is 90 and 120 degrees. Right. The second question is predict whether the molecules phosphorus trifluoride and phosphorus pentafluoride are polar or nonpolar. Okay. This is simple. So phosphorus trifluoride is polar because it has a lone pair here, meaning it has a net dipole facing down, whereas this one has no lone pairs, which means you can say all of the atoms just sort of stretch out, which gives us a net zero dipole. So We say PF3 is polar than PF5. Alright, so last question. For question 4, state the type of hybridization shown in phosphorus atom in PF3. So it has 4 electron domains surrounding itself, meaning it is an sp3 hybridized. And that's it. That's question 4 complete. Thank you.